Okay, here we are with special parallelograms. Just a reminder from yesterday that a parallelogram is a quadrilateral where both pairs of opposite sides are parallel. So the things that we're going to cover today are rectangle, rhombus, and square. And we are going to continue our parallelogram properties. And whenever we get to these special parallelograms, not only will they have every single quality that a parallelogram has, we're going to add things to it. So for our rectangle, if I go ahead and draw one out here, remember, be as specific as possible in your drawings. So if I have a rectangle, it is a parallelogram. And the only thing that makes it a rectangle is that I have 4 right angles. So we have a parallelogram plus 4 right angles. All right, a rhombus. I think of it as a squished square. So we've got this here. It's fairly close. It'll be all right. I'm going to go ahead and mark it as a parallelogram. And the only thing that takes us from a parallelogram to a rhombus is that I have 4 sides that are congruent. So I have a parallelogram plus 4 congruent sides. And then I'm pretty sure you guys know the result of a square. I'm going to have not only a parallelogram, but I'm going to combine the properties of a rhombus and a rectangle. So not only is it a parallelogram, I have 4 right angles and 4 congruent sides. So yes, it is both a rectangle and a rhombus. Here is a flowchart that I created for what we're doing with this at-home learning. We're not actually going to be using trapezoids and kites, but if you want to go back and take a look at some of those, then go ahead. If we look over here in our parallelograms column, parallelograms, there are all of our properties. Opposite sides congruent and parallel, opposite angles congruent, diagonals bisect each other, and consecutive angles are supplementary. Once we get beyond that, our rectangles have everything up above. We have 4 right angles, and as soon as we take that squished rectangle and add in those 4 right angles, I now have congruent diagonals. So not only those diagonals bisect each other, they are also congruent to one another. For our rhombus, we include 4 congruent sides, and also with the rhombus, our diagonals bisect the angles that they meet, and our diagonals are perpendicular, plus everything from up above. And for our squares, anything listed in that parallelogram section applies to our squares. So one of the things that was key in our Unit 6 was an always, sometimes, never. If you take a look in this section here, if I start up at a parallelogram is sometimes a rhombus, but a rhombus is always a parallelogram. So if we're working from the bottom all the way up to the top, a square is always a rhombus, a square is always a rectangle, and a square is always a parallelogram. Working our way down is where we're going to end up with that sometimes. From a rectangle is sometimes a square. Now, if you include the rest of the diagram here, if I'm going from category to category, that's when we're going to have our never statements. A parallelogram is never a kite. A parallelogram is never a trapezoid, and vice versa. So here we have rectangle. Couple of things that you need to know based off of that word rectangle alone is that we have opposite sides that are congruent. I have 4 90-degree angles, and I have congruent diagonals. Oops, I can't spell. Okay, so if AC has, we're trying to find AC. If AE has a length of 15, then so does EC. So AC has a value of 30. BD will also have a value of 30 because in a rectangle our diagonals are congruent. BE will be half of that 30. And AB will match its opposite side at 24. And BC, we will have to use some trig. No, Pythagorean theorem. So I've got my right triangle. The base is 24. The diagonal is 30. So if I do a squared plus 24 squared equals 30 squared, and I go ahead and work all of that out. Let's see, 30 squared minus 24 squared. That is an a squared is equal to 324. And if I take the square root of that, I end up with 18. And I've got another rectangle here. I've got 90-degree angles. Remember that vertical angles are always congruent, and I always have those linear pair angles in the middle as well. So if I do 180 minus 64, that'll give me a value of 116 here. And if you think back to how all of these are going to be congruent, then we're splitting ourselves into some isosceles triangles. So if I do 180 minus 64, that gives me 116, and if I split that in half, I end up with 58 here and here, as well as those two. And then if I do 116, that gives me 64, so I'm going to have 32 and 32. And just to double check, if I add 58 and 32, that does give me 90, so we should be good to go. All right, so the measure of angle BAC is going to be 32 degrees. DAC is 58. AEB is 116. And ADB is 58. Here is our rhombus. A couple of things about a rhombus. Remember, we're dealing with angles here. So our diagonals are meeting at a 90-degree angle. And we have our alternate interior pairs. So I have 25 here and 25. This will be 90 right here as well. This will be congruent, and so will those. So let's work our way around. It looks like from here we will have to find angle 5. So if I find angle 5, I'm going to do 180 minus 90 minus 25, which gives me a value of 65, which will give me 65 here. And it looks to me like we have a bunch of congruent triangles. They'll be congruent, what, side angle side. So if I've got 65 there, 90 here, then my other angles should also be 25 and 65, 25 and 65. And also remember that in a rhombus, the diagonals are bisecting the angles that they are hitting. So angle 1 will have a measure of 65, so will angle 2. Angle 3 and 4 will both be 25 degrees. Angle 5 and 6 will be 65. and 7 will be 25, and 8 is our 90. All right, so here we have our rhombus with BC with a measure of 23 and AC all the way across with a length of 40. So I'm going to go ahead and split this into 20 and 20. I've got a 90-degree angle here. Wants us to find the measure of AB as well as AE. I already have that listed as 20 because it's being bisected. And EB. So let's work some Pythagorean theorem here. Remember, well, first, this is a rhombus, so all of my sides are going to be congruent. So AB will have a value of 23. And then to find EB, we'll use Pythagorean theorem. So I'm going to have 20 and 23 and x. So 23 squared minus 20 squared gives me an x squared of 129. Let's see, if I divide that by 3, I end up with 3 times 43. And I believe that 43 is prime, so we're going to have the square root of 129 as the length. And a square. If ABCD is a square, AE is 2x plus 13. EC is 8x minus 41. It wants us to find the length of BD. So because this is a square, that is a rectangle, our diagonals not only bisect each other, but they will also be congruent to one another. So AE and EC, DE, and EB will all be congruent. If they're all congruent, I can set AE and EC equal to one another. So 2x plus 13 is equal to 8x minus 41. If I do 13 plus 41, I end up with 54. Subtract the 2x is 6x, so x is equal to 9. And then if I go ahead and plug that in, I've got 18 plus 13, which gives me a value of 31. And that will also be consistent here and here and here. Just to double check, I'm going to do 8 times 9 is 72. Minus 41 does also give me 31. And to get BD, I'm going to add those two together. So BD is going to be equal to 62. And the measure of ABE is 5x. Solve for x. So I'm going to go ahead and erase this work over here. Remember that this is a square, so I'm going to have a perpendicular where the diagonals meet because a square is always a rhombus, and I'm going to have an isosceles triangle. So this will have a value of 90, and if ABE is 5x, so will BAC. So I've got 90 plus 10x is equal to 180. 10x is equal to 90, so x is equal to 9. All that we're going to have to work with is this left-hand side of the column. We'll go into more detail on that tomorrow, and determining what types of quadrilaterals we have. So make sure that you study this left-hand column over here